chapter 7, section 6 is on the nth roots. Okay, so here's some definitions, and I'm going to read them all to you, and then don't freak out, but because I think it'll make sense. So you know that 6 squared is 36. So you know the square root of 36 is 6. Therefore, 36 to the 1/2 is 6. Okay, so a different way of writing the square root, basically, instead of writing the square root, you can write to the 1/2 power. Okay, so keeping that idea in mind, we know that 2 to the third is 8. Therefore, the third root of 8 is 2, and 8 to the 1/3 then is 2. So it's basically kind of working yourself backwards and then putting a 1 over that. So we know that 3 to the 4th is 81. So the fourth root of 81 is 3, and then 81 to the 1/4 is 3. Okay, so if we know that 10 to the 5th is 100,000, then the fifth root of 100,000 is 10. Therefore, 100,000 to the 1/5, good, is 10. Okay, so you're just kind of working yourself backwards. It's just a different way to say things. So instead of writing third root and fourth root, we're going to write it to the 1/3 and 1/4 power. Okay, so when you are evaluating these things, you're going to say to yourself, okay, what to the third power is 27? Well, that would be 3. Okay, so 27 to the 1/3 is 3. So 32 to the 1/5 says what to the 5th power gives me 32. What to the 5th power is 32, and that is 2. Okay, so you're saying what to the bottom number gives you the actual base. Okay, so this is where that power sheet, all those things that you said you had memorized, really comes into play. So part A, 25 to the 1/5, that says what to the second power, and if you want to write it out like, okay, what to the second power is 25, well, that's going to be 5. Oh, I definitely just did that wrong. No, I didn't. You're good. Okay, so here we're going to say what to the third power is 64. Well, that's 4. Okay, and now C is a little trickier. I have 1/16 to the 1/4. Okay, so that's basically like saying 1 to the 1/4 over 16 to the 1/4. Okay, well, 1 to any power is 1, and then the bottom part, 16 to the 1/4. What to the 4th power is 16? Well, that'll be 2. So your final answer there is 1/2. Okay, so D is the same thing. We're going to say 16 to the 1/4 and then 625 to the 1/4. Okay, so distributing that power to both of those. So what to the 4th power is 16? We just said that was 2. And then on the denominator, what to the 4th power is 625? Well, that's 5. So our final answer there is 2/5. Okay, letter E is getting a little trickier. Now we're saying what to the third power is 125? Well, that's 5, and then that negative goes out front because that's the opposite of that. So that's a -5. So we're also watching our signs here. And then letter F, what to the 5th power is 32? Well, that's 2, and then the negative at the end makes that answer a -2. Okay, so then let's go ahead and try and solve them. So now we're saying what to the third power is 216? Well, that is going to be 6. Okay, letter H, if I have 3 x to the 1/2 equals 27, the first thing we have to do is divide each side by 3. So that's going to give me x to the 1/2 to be 9. Okay, now this is a little trickier to think of x to the 1/2 to be 9. So if you want to get rid of that power, you can actually take the reciprocal to each side. So if I raise 1/2 squared, then the 2 and the 1/2 cancel, so I just get x, and then 9 squared would give me 81. Okay, so if you can't think of it like you did in example G where you know that 6 to the third is 216, you can actually raise each side to the reciprocal so that we can actually solve for it that way. Okay, so in example I, we might want to kind of do that same thing. So the first thing you're going to do here is add 8. So I'll have x to the 1/4 equals a -2. Okay, again, this is maybe an idea where we're going to want to raise each side to the reciprocal. So we're going to raise each side to the 4th power. So the 1/4 and the 4th cancel. So I'm going to get x to equal. Now careful here, when I take a -2, notice I put my parentheses around the -2 and raise that to the 4th power. That's going to give me a +16. Okay, so it's not a -16 because those parentheses go around the -2. Okay, and that power is even, so it's +16. All right, so we'll look at j. Okay, we'll divide by 2 first. So we'll have x squared equal a negative 64. Okay, well, if I just look at that right now, you're going to say, can a square ever give me a negative? And that is no. Okay, so if I ever get something that needs to be to an even power to give me negative, that's going to be no solution. Now, you might remember that we have used imaginary numbers. Okay, however, that was a very special case, and right now we're not using imaginary numbers, so we're going to say no solution. Okay, so if it would, because some of you are like, oh yeah, I remember square rooting that, and that get me plus or minus 8i. Okay, well 8i is imaginary, so for right now we're just going no solution. So let's try example K. 4x to the 1/5 minus 3 equals 9. Okay, so I should add my 3 first. So I'll get 4x to the 1/5 equal 12. Then I'll divide by my 4. So then x to the 1/5 will give me 3. And then to undo a 1/5 power, we'll raise each side to the 5th. So the 1/5 and the 5th cancel. So 3 to the 5th is 243. Okay, and I hope you're remembering these are all no calculator type problems. Okay, I think you should be able to do everything there without a calculator. So remember those power sheets. If you forgot them, then you're going to want to start putting those to your memory a little bit more. Okay, example L. 6x to the third plus 18 equals 3090. So I'd subtract 18 first. So I get 6x to the third equals 3072. Divide that by 6. So I get x to the third equal 512. Okay, maybe that's a little mean for no calculator, so probably nothing that bad. So I'm saying what to the third is 512, okay, and that's 8. Okay, if you can't think of it that way, you can also raise it to the 1/3 power on each side, because 3 and 1/3 will cancel, and then 512 to the 1/3 is 8. So kind of the same idea, just either doing it mentally or writing that out. Okay, so we have kind of already run into this, so we're going to kind of just put it into a table. If you ever have an even exponent, okay, and you have a positive number, then you're going to have two answers, right? Plus or minus. If you have a negative and an even, we're going to have a no solution here, okay? And if you have odd and negative, you're going to have 1, and negative and odd is 1. Okay, so we kind of already talked about that, but we can just kind of put that into a table. So if you have n for your exponent, you're always going to have an odd, or if n is odd, you're always going to have 1. If n is even, that's where you run into trouble. So it's 2, remember, plus or minus if you have like the square root, or 0 if it's negative. So then n through p just ask us to say how many. So the 6th root of a negative, so this is even and negative, is no solution. So I want even and negative is no solution. The 7th root of 68, well, 7th is odd, and odd always has one answer. Okay, O, odd, okay, always has one answer. 8 is even, and positive means we're going to have 2. Okay, so those are things we kind of already talked about, and that's just kind of putting it into a table and clarifying it. Okay, so hopefully today went well, except for maybe you just need to remember some of those powers a little bit better. But if you still have questions, go ahead and write them down and bring them to class tomorrow.